Hi everyone, today we will learn about topic 6, which is discrete probability distribution. In this topic, there are 3 subtopics. The first one is about 6.1 introduction, 6.2 binomial distribution, and 6.3 Poisson distribution. Generally, this is the rough idea about topic 6. First, we will learn about 6.1 introduction. Under this subtopic, we will know about discrete random variables and also continuous random variables. Under discrete random variables, there will be 6.2 binomial distribution and also 6.3 Poisson distribution. Whereas for continuous random variables, we will learn in details about this in topic 7, which is normal distribution. Furthermore, under 6.2 binomial distribution, you will learn about how to define binomial distribution, where we can write such that X distributed to B and P. So these are the information that you need to know in binomial distribution. More than that, you will learn about how to find the mean or the expected value for the binomial distribution, and also variance and standard deviation. So these are the formula involved in finding mean, variance, and standard deviation respectively. Whereas for Poisson distribution, you also need to know the definition of the Poisson distribution. So these are the definition. So here you can see what are the information that you need to know in order to define the Poisson distribution. Meanwhile, there is also the mean and variance for a Poisson distribution. So please take note, for mean Poisson distribution, you will write such as mean equals to lambda. For variance, variance is equals to lambda, and standard deviation is equals to Z lambda. So from here, you can see that under binomial distribution, you need to know the definition and also the information in the binomial distribution, such as mean, variance, and standard deviation. Meanwhile, it is the same thing for Poisson distribution, where you need to define the Poisson distribution. And then you also need to know the mean and variance for a Poisson distribution. So generally, this is the rough idea about topic 6. Now let's continue with lecture 1 of 5, 6.1 introduction. Learning outcomes in this lecture are: the first one, you need to define the random variable. Second, you need to identify discrete random variables and continuous random variables. And the last one, you need to define the probability distribution. For introduction, let's define the random variable first. A random variable is a variable whose value depends on the outcome of a random experiment. Next, we need to identify whether the random variable is discrete or continuous random variables. So here, there are 2 types of random variable. The first one is discrete random variable, and then the second one is continuous random variable. Now let's move to the box which is in green color. So the box stated about discrete random variable. What is discrete random variable? A discrete random variable is a random variable that assumes countable values. In other words, it is whole numbers. Let's look at the examples of discrete random variables. The first one is the number of new accounts opened at a bank during a certain month. B. The number of vehicles owned by families. C. The number of students who drive to college each day. If you can see from the examples, we know that the value will be in the whole numbers. So that's why this will be the discrete random variable. Whereas for continuous random variables, which is in the blue box here, continuous random variables cannot have exact values, but they can have any values within an interval. Some examples of continuous random variables are the weights of newborn babies in a country, B. The time students spend doing homework, C. The price of a concert ticket. If you can see from the examples of continuous random variables, the values will be in decimal places. For examples, the weights of newborn babies, it could be 4.56 kg. Meanwhile, the time students spend doing homework, it can be 1.5 hours. The next one, the price of a concert ticket. If you are aware, in RM, we also has cent. That's why, for price, for example, we will write such as RM 12 ringgit and 50 cent. From here, you can see the continuous random variables, the values can be in decimal places. Meanwhile, for discrete random variables, the values must be in whole number. It cannot be in decimal places. For example, the number of vehicles. We cannot say the number of vehicles is 10.5, right? So, discrete random variables, the values must be in whole number. Whereas, for continuous random variables, the values must be uncountable values. Or in other words, it should have decimal places. Now, let's move to define the probability distribution. What is probability distribution? The first one, probability distribution is actually a function that is used to define a discrete random variable. It is also known as probability distribution function, denoted by PDF. Secondly, the probability distribution of a discrete random variable is list of all possible values that a random variable can take on together with the associated probabilities. The third one is the probability distribution is usually denoted by capital letter P in bracket capital letter X equals to small letter x and read as the probability when a random variable x is x. For example, if we write such that P x equals to 1, so we can read such as the probability when a random variable x is 1. Notice the different uses of capital letter X and small letter x, where capital letter X is the random variable. Example, the sum of the scores on 2 dice. Whereas for small letter x is a value that x can take. For this example, which is the sum of the scores on 2 dice, we can write our small letter x such as 2. Why 2? Because the least point on a die is 1. If there are 2 dice, therefore we will have 1 plus 1 will be equals to 2. The next one, we are going to have 3, 4, 5 up until 12. Why 12? Because the most point on a die is 6. If there are 2 dice, so 6 plus 6 will be equals to 12. So that's how we differentiate the capital letter X and the small letter x. Let's look at examples by Madam Norain.
Next, consider the experiment where two coins are tossed simultaneously. Let X be a discrete random variable, that is, the number of heads obtained when the two coins are tossed. Let H is denoted for head and T is denoted for tail. When we toss two coins simultaneously, then the possible outcomes are 2 heads, 1 head, and 2 tails. Therefore, total number of outcomes are 4. So, when two coins are tossed, the number of heads obtained is 0, 1, and 2. Therefore, X can take the values 0, 1, and 2 only. Therefore, the probability of getting no head is PTT equal 1 over 4. The probability of getting 1 head is PHT plus PTH equal 1 over 2. And probability of getting 2 head is PHH equal 1 over 4. The sum of all the probability is equal 1. The probability distribution of this discrete random variable X can be represented by the table. From this table, Px equal 0 is 1 over 4, Px equal 1 is 1 over 2, Px equal 2 is 1 over 4. The above relationship can also be written as a function. Fx equal 1 over 4 for x equal 0 and 2. Fx equal 1 over 2 for x equal 1 and 0 otherwise. Fx is called the probability distribution function. The probability distribution function can also be represented by a graph. Okay, from graph, F0 equal 1 over 4, F1 equal 1 over 2, F2 equal 1 over 4. Two characteristics of a discrete random variable are the probability of each value of a discrete random variable is between 0 and 1, and the sum of all the possible probability is 1. Example 1. Show that Fx equal x squared over 55 for x equal 1, 2, 3, 4, 5 is probability distribution function of a discrete random variable x. Hence, find A. Probability of x equal 3, B. Probability of x more than 3, C. Probability of x less than equal 3, D. Probability of x more than 2 less than equal 5, E. Probability of x more than equal to less than equal 4. So, to show this is probability distribution function, we need to show that the sum of all the probability is 1. The function given is x squared over 55 for x equal 1, 2, 3, 4, and 5. To find the sum of all the probability, we substitute x equal 1, 2, 3, 4, and 5 in this function. So, we get 1 squared over 55 plus 2 squared over 55 plus 3 squared over 55 plus 4 squared over 55 plus 5 squared over 55, and we get 1. Therefore, fx is a probability distribution function of a discrete random variable x. How to evaluate px equal 3? Okay, px equal 3 is f3. To find f3, we just substitute x equal 3 into given function. So we get 3 squared over 55, and the answer is 9 over 55. How to find px more than 3? Okay, the value of x is 1, 2, 3, 4, and 5 only. So, px more than 3 is px equal 4 plus px equal 5 only. So, we substitute x equal 4 and x equal 5 into given function, and we get the answer is 41 over 55. C, p at less than equal 3. Okay, the given function is fx equal x squared over 55 for x equal 1, 2, 3, 4, and 5. So, px less than equal 3 equal px equal 1 plus px equal 2 plus px equal 3 only. So, px equal 1 is f1, px equal 2 is f2, px equal 3 is f3. We just substitute x equal 1, x equal 2, x equal 3 into given function. So, the answer is 14 over 55. D, probability x more than 2 less than equal 5 is probability x more than equal 3 less than equal 5. Means we have to find the sum of probability x equal 3, x equal 4, and probability x equal 5. So, we just substitute x equal 3, x equal 4, and x equal 5 into a given formula. So, we get 3 squared over 55 plus 4 squared over 55 plus 5 squared over 55, and the answer is 10 over 11. E, the probability of x more than equal to less than equal 4 is px equal 2 plus px equal 3 plus px equal 4 is f2 plus f3 plus s4. We just substitute x equal 2, x equal 3, x equal 4 into formula given. So we get the answer is 29 over 55. Example 2. The probability distribution for the random variable x is shown in the following table. A. Determine the value of k. B. Find the probabilities. B1 exactly 2, B2 more than 2, B3 at least 2, B4 at most 3, B5 1 to 3, B6 between 1 and 4. C. Sketch the graph fx. Okay, we know that the sum of all the probability is equal 1. So, from the table given, we get Probability x equal 0 is k. Probability x equal 1 is 2k. Probability x equal 2 is 2k. Probability x equal 3 is 3k. Probability x equal 4 is k. And last, probability x equal 5 is k. Okay, next, we try to find the sum of all possible probability px equal 0 plus px equal 1 plus px equal 2 plus px equal 3 plus px equal 4 and plus px equal 5, and all must be equal to 1. And then we have k plus 2k plus 2k plus 3k plus k plus k equal 1, and we get 10k equal 1, and we simplify, we get the value of k is 1 over 10. B1 exactly 2 means we need to find the probability of x equal 2. From the table given, we know that probability of x equal 2 is 2k. Then we sub k equal 1 over 10. Hence, the probability of getting exactly 2 is 1 over 5. B2 more than 2. How do you write more than 2? Okay, this is the sign more than. More than 2 means 2 is not included. So, probability x more than 2 is the sum of probability x equal 3 and probability x equal 4 and probability x equal 5. So, from the table, we have 3k plus k plus k, and we get 5k. We substitute k equal 1 over 10. Hence, the probability of x more than 2 is 1 over 2. B3 at least 2. What is the sign for at least? Okay, this is a sign for at least, that is more than or equal. So, x more than or equal to means 2 is included. So, we start from x equal 2. And probability x more than or equal to is probability x equal 2 plus probability x equal 3 plus probability x equal 4 plus probability x equal 5. Okay, from the table given, we have 2k plus 3k plus k plus k. And then we get 7k. We substitute k equal 1 over 10. And the answer is 7 over 10. 4 at most 3. Okay, this is the sign for at most. The sign is less than or equal. So, x less than or equal 3 means the value of x can be 3 or less than but cannot be more than 3. Okay, from this table, we know that probability at less than equal 3 is probability x equal 0 plus probability x equal 1 plus probability x equal 2 and plus probability x equal 3. So we have k plus 2k plus 2k plus 3k, and we get 8k. we substitute k equal 1 over 10 and we simplify. We have the answer 4 over 5. B5 1, 2, 3 means 1 and 3 are included. So we have x equal 1, x equal 2 and x equal 3. The possible sign is x more than or equal 1 and less than or equal 3. So the probability x more than equal 1, less than or equal 3 is, we find the sum px equal 1, px equal 2 and px equal 3, and then we sub the value of px equal 1, px equal 2 and px equal 3 and we get 7k. So we substitute k equal 1 over 10 and we get the answer 7 over 10. Sit between 1 and 4. Between means 1 and 4 are not included. So we can write it x more than 1, less than 4. So we have only x equal 2 and x equal 3. Okay, to find probability x more than 1 and less than 4, we add probability x equal 2 and probability x equal 3. Okay, and we get 5k. We simplify, hence the probability of x between 1 and 4 is 1 over 2.